Let's go to guided practice 3. Let A and B be independent events, where P of A equals 0.3 and P of B equals 0.6. Since A and B are independent events, according to the definition of independent events, we have a probability of A intersection B equals probability of A times the probability of B. So we substitute here the 0.3 times 0.6 equals 0.18. Find the probability of A union B. Addition rule of probability. That is the probability of A union B equals probability of A plus probability of B minus probability of A intersection B. So we do the substitution. Probability of A equals 0.3 plus 0.6 minus 0.18 equals 0.72. For say, on the following Venn diagram, shade the region that represents A intersection B prime in A but not in B. So will be this part. Find the probability of A intersection B prime. We do know this is 0.18. Since the probability of A is 0.3, so 0.3 minus 0.18, that equals 0.12. This will be 0.12. Let's go to guided practice 4. Consider the events A and B, where probability of A equals 0.5 and probability of B equals 0.4, and probability of A intersection B equals 0.3. So we have 0.3. For P will be 0.5 minus 0.3, that is 0.2. For this Q will be 0.4 minus 0.3 equals 0.1. This R we can figure out by doing 1 minus. P will be 0.2, then minus the intersection of A and B, then minus 0.1. So we have 0.4. We figure out P is 0.2, Q is 0.1, R equals 0.4. For B, find the value of probability A given B prime, which means the probability of A intersection B prime all over probability of B prime. For the probability of B prime, we will use 1 minus probability of B. Probability of A intersection B prime will be in A but not in B. So it's P 0.2 over 1 minus 0.4 equals 0.2 over 0.6 equals 1 over 3. Let's go to say, hence or otherwise. Show that the events A and B are not independent. If two events are independent, which means probability of A intersection B equals the probability of A times the probability of B. We need to check probability of A times the probability of B equals 0.5 times 0.4 equals 0.2. Then probability of A intersection B equals 0.3. Since probability of A intersection B not equal to probability of A times the probability of B. So events A and B are not independent. Let's go to guided practice 5. At a large school, students are required to learn at least one language, Spanish or French. It's known that 75% of the students learn Spanish and 40% learn French. At least one language, Spanish or French, which means the probability of Spanish union French equals 1. So we will draw outcomes, French and Spanish. For A, find the percentage of students who learn both Spanish and French. Basically, we're looking for probability of French intersection Spanish. We will use addition rule. For addition rule of probability, probability of A union B equals the probability of A plus probability of B minus the probability of A intersection B. From this addition rule, we can get probability of A intersection B equals probability of A plus probability of B minus probability of A union B. So probability of French intersection Spanish equals probability of French plus probability of Spanish minus probability of French union Spanish. Then we do the substitution. Probability of French, that is 0.4 plus for the probability of Spanish, then minus 1 equals 0.15. Then you need to change it into percentage, 15%. 15%. B, find the percentage of students who learn Spanish but not French. Let's fill out this Venn diagram. This is 0.15. Then probability of French intersection not Spanish equals 0.4 minus 0.15. That equals 0.25. So we have 0.25. For this part, probability of Spanish intersection not French will be 0.75 minus 0.15 equals 0.6. 0.6. So for B, find the percentage of students who learn Spanish but not French will be this part. Change into percentage will be 60%. At this school, 52% of the students are girls, and 85% of girls learn Spanish. Let G be the event that students is a girl, and S be the event that the students learn Spanish. So we have a probability of J equals 0.52. Then probability of Spanish given girls will be 0.85. Now let's look at the C1. Find the probability of J intersection S. When you look for the probability of intersection, there are two ways to figure this out. One way, we can use the addition rule of probability, which equals probability of A plus probability of B minus probability of A union B. Second way, you can figure out probability of intersection by conditional probability. We do know probability of A given B equals probability of A intersection B all over probability of B. And from this, we can get the probability of A intersection B equals probability of A given B times the probability of B. Also, if probability of B given A, that equals probability of A intersection B over probability of A. From this formula, we can figure out probability of A intersection B equals probability of B given A times the probability of A. Just remember, this is a B, then you multiply by, this is a B. This is A, you multiply by probability of A. Probability of A intersection B equals probability of A given B times the probability of B. Also equals probability of B given A times the probability of A. So for this probability of J intersection S, we can write down probability of J given S times the probability of S. Or we can write down probability of S given J times the probability of J. From the given information, we know probability of J is 0.52. Probability of S given J is 0.85. So we can use this formula that equals 0.85 times 0.52, 0.442. C2, show that J and S are not independent events. Probability of J intersection S, we already figured out that is 0.442. But probability of J times the probability of S equals, we know probability of girls is 0.52. Probability of Spanish is 0.75. So we have 0.52 times 0.75 equals 0.39. Since probability of J intersection S is not equal to probability of J times the probability of S, we can draw a conclusion that J and S are not independent. Let's go to D. A boy is chosen at random. Find the probability that he learns Spanish. A boy is chosen at random. This will be conditional probability. We are looking for probability of Spanish given boys. Using formula, we will get probability of Spanish intersection boys all over probability of boys. Probability of boys, we can use 1 minus. Probability of girls is 0.52. So minus 0.52, we can get the probability of boys. Since the probability of Spanish equals the probability of Spanish intersection boys plus probability of Spanish intersection girls. Probability of Spanish, we already know that is 0.75 equals probability of Spanish intersection boys plus probability of Spanish intersection girls, we already figure out it's here, 0.442. Therefore, probability of Spanish intersection boys will be 0.75 minus 0.442. 0.642 is the solution for probability of Spanish given boys.